Bro.
Dude.
Bro. Bro. I can't draw a picture. You and your girl. I do a picture of him and girl. Look, bro.
That's not what you did. That's not
Not an insult in here. It's not an insult in here. And I mean, dude, look at the flags literally around my desk. Hot glued to the edge of my desk.
Yeah, right.
This is a safe space.
Bro.
All right. So we are going to start talking about exponential growth. And I am going to want you to write this at the top of page 108. It is not written there, but you're going to want to have it, this formula. Because this is going to be how we start looking at these functions and looking at these rules. This is going to have quite a few story problems. There's very few problems we're going to do in this chapter that are not story problems, just because they're trying to make everything context-based. So we've got here that the North Dakota has the fastest growing population in the United States. And in 2013, the population was 700,000 people. They've been growing by, 5% per year. So we want to be able to estimate their population this year. So what we have is we have a formula up here that's expecting us to know how to put it together. And they don't even give you this on the page. So they really expected you to kind of remember how to put these together. So what we have in this, and I'm going to write it down under here so we have it, our A equals P1 plus or minus R to the T. So this A stands for the amount. This is the amount we're looking for, or the new total. I'm pretty sure I just spelled amount wrong, but you get the vibe. I think there's only one M. This P is our initial population. When we're looking at money, population, it also can be called the principal. And that just means our starting amount. One is the number R. Okay, that definitely did not come out of my face the right way. 1 is the number 1. It's with the letter R. And R stands for rate. So this is going to be our rate, whether it's growing or getting smaller. This is our rate, and it's really, really critical that we have it as a decimal. It has to be as a decimal. Very rarely is it given to us as a decimal, but it has to be in the formula as a decimal. And then our last piece up here is this T, and T is time. So there's a lot of information in this paragraph that is going to help us figure out an equation to write. What pieces do we see in this story that might help us? The initial population. What's the initial population? 700,000. So this right here is going to be our principal, our initial population. So when we are writing an equation, we can put that 700,000 out in front. What else do we know?
We got 1 plus minus 0.05.
So I am with you on the 0.05. So our rate as a decimal is our 0.05 because we're writing that 5% as a decimal. Do we need to do two equations? No. Are we going to use plus or are we going to use minus? Plus. How do we know? Because our population is growing. Since it's growing, we use a plus. What's going to be our t? Do we have to find that out? Man. Because what are we going to put for t?
I mean, we don't have anything but like per year. That's not really like.
Right. I want to know what the population is this year, right?
So new Or
What year is this year?
22. Oh. Wait, actually, like right now?
Right now.
Oh, 24.
2024.
11?
What year did they start collecting data? 2013. So how many years has it been? 11 years. So the way we're finding our t, and I'm just going to write it down so we have it, is we're taking our 2024, that's this year, and we're subtracting our 2013. It's how many years it's been. So the year we want to know about is 11 years from the start of collecting data. So they're not always going to tell you, all right, tell me what it is in 11 years. They're going to say, we started collecting in 2013. We started collecting in 1905. Figure out how many years it's been. So we just subtracted it. So that's going to give us our estimate for the population. So what we're going to do is we're going to simplify this a little bit before we type things in the calculator, because this is a bit of a mess. So I'm going to simplify my what's in the parentheses. I'm going to do this addition. So we're going to have our 700,000. And we're going to do 1 plus 0.05, which is 1.05 to the power of the 11th. And what we're going to do is we're going to go to our calculators, which I have one here, is thinking. There we go. Don't get freak out. That was freak out. And we're going to do that. We're going to do our 700,000. Make sure you're getting enough zeros in there. Yep, I got them all. And we can write it exactly the way we have it here. Like, we don't have to switch it to be multiplying. We can just put it as parentheses. So we're going to do our parentheses, 1.05, and close it. The way we get that exponent that's not a 2 is this button. It looks like a little bitty up arrow. It's just above the square, and it puts you up into the exponent, and it doesn't pre-type a number in. So I can type in my 11. And on these yellow calculators, it looks all nice and small like that. If you are bound and determined to use your phone calculator, you are going to have to manually do your order of operations. Meaning you're going to come through and you're going to do this, whoa, laser pointer, this piece first. You'll have to do the exponential, oh, I'll do it on the big screen. You'll have to do the exponential piece first and then do your multiplication. So we simplify our parentheses, then we do our exponents, then we multiply. So if you're going to use your phone, you got to do it yourself because your phone's not smart enough to do order of operations. They are stubbornly refusing to do so. So here is our calculator's answer. So we have that the amount we've calculated was 119,723, I forgot by now, 7.551. 7.551. So we have 1.197 million. What is this about again?
The population.
the population, which is made up of what? People, right? Can I have 0.5 people? Do not throw half of a person into the town. It will affect your population. So what are we going to do? Round that which way? Are we going to round up or are we going to round down? If it's 0.5. Round up. So we have 1,238-ish people, because we're making estimates anyway. But do not tell me you have a half of a person in your state. Yes, Meteor. Technically, children still count as whole people. They do not get a sliding scale of personhood. I've had this conversation several years. Amputees still count as whole people. Pregnant people still count as whole people. Yes, dear.
My dad is here.
Uh-huh.
But he said that they're not sending a back system.
Oh, system is down. Yes. You have to go check something at the front office, right, Jeremiah? You just have to go check something at the front office, right?
Huh?
You have to go check something at the front office,
Yeah,
right?
I gotta go,
gotta
see a
check it.
counselor or something.
Right.
Or something.
Yeah,
Gotta do that, gotta do that.
exactly. Parking pass, something.
Yeah.
I measured back on that. Yeah, we can't mark attendance or anything right now. Like the one day I actually remember in this class, and the stuff we're going down. Okay, so this is how we're going to be starting these things out, looking at these kinds of problems, working on them with this equation. Questions on any of the things we've done here, or any of this stuff? Yes. I know. I'm so mean. It's the next one, though. It's not particularly more challenging. It is the next question on the page. Okay? And it might... No, I don't think it even takes any from the next page. I think it's just question number 2. Okay? Also, if you're stressing about homework, due dates are relative. You can always go back and catch them up when we need to. All right? You guys have 6 minutes to the end of the period. And these, I would say they don't get too much work, but they really do. Just saying. Sorry.